Unit 4, Lesson 1, Solving Quadratics by Graphing. So you're going to be solving equations. So if you recall from the Desmos activity you'll be doing in class, or you will have done in class, solving a quadratic equation means to determine the value or values of the variable that make the equation true. In other words, left side of the equation equals the right side of the equation. This is just like linear equations, right? You're solving for that x variable. What x variable makes the left side equal the right side? So example, you had x squared equals 9. What value of x makes this true? Well, you would say x equals 3. Or you could say negative 3, right? Another equation we're going to be learning to solve is something like this. X squared plus x minus 6 equals 0. What value of x makes this true? Now, the first method of solving in this lesson, or the first method we're using in this course, is by graphing. So when you're to solve by graphing means you're going to find the x-intercepts. So you first see, well, is your equation, so when is your equation? Is your equation equal to 0? So when your equation is equal to 0, you graph the that quadratic. Graph the quadratic, and the solution to that quadratic would be to find those x-intercepts. So find the x-intercepts. This works because y is equal to 0. The other side of your equation is equal to 0. Okay? But what if the other side of your equation is not equal to 0? So when not equal to 0, you have to rearrange so that the equation is equal to 0, and then repeat, find those x-intercepts, or you graph the left side and the right side, and as you graph both the left side and the right side, you find the point of intersections. Where do those graphs meet? So find the POIs. So for example, if you solved x squared minus 6x plus 8 equals 0, you graph it. Okay, and when you graph it, you'll see that your graph has two x-intercepts, one at -4 and -2. So your solutions are -4 and -2. Okay, and both of these x values will satisfy the equation so that the left side equals 0, equals the right side, which is 0. Okay? But if you graphed x squared minus 3x minus 19 equals 9, well, if you look at that graph, the left side, or that equation, the left side equals the quadratic, the right side is the number. So you either want to, you're going to have to maybe graph both. So if you graph both the parabolas, the quadratic is what I have on the left side, and you graph the right side, which is just y equals 9. So let's, right here, here's y equals x squared minus 3x minus 19, and I graph the line y equals 9, and you check where does your quadratic meet that line. Well, it meets them at -4 and +7, and so that's your solution, x equals -4 or 7. The alternative is to rearrange the equation by making it equal to 0. So that means you have to subtract 9 from both sides. So you would end up graphing x squared minus 3x minus, so 19 minus 9 is 28, so minus 28 equals 0. If you graph this, you'll also get the solution. So if I graphed, I would also get the solution of -4 and +7. So here's where you're checking the x-intercepts. because your equation is equal to 0. All right, other examples. The path of a stone thrown into a ravine is modeled by the quadratic y equals negative x squared plus 5x plus 84, where x represents the distance in meters traveled horizontally and y represents the height in meters above the surface of the river at the bottom of the ravine. How far does the stone travel? So the bottom of the ravine is when you have y equals 0. So let's make a note of that. So the bottom of the ravine, y equals 0. Okay, and so we're going to determine the x-intercepts. Okay, and so if you graph that parabola, you're going to have, remember, the standard form, 84, that's my starting point, initial value. So if you graph the parabola, you will see that the stone thrown into the ravine will hit the bottom at 12 before it hits the water. So it travels horizontally 12 meters before it hits the water. Now it doesn't matter on the left side of the parabola because we're not throwing it backward, we're not throwing it into the ground. It just says the stone travels horizontally and y represents the height. So we're looking at how far does the stone travel horizontally. So we're looking at this horizontal distance right here. If I highlight it, this is it. Okay, so it travels a horizontal distance of 12 before it hits the water. So you're looking at what's that x-intercept just before it hits the water. So here we're going to say, therefore, the stone travels 12 meters horizontally before it hits the water. Okay, another example. A rectangle has dimensions 3x plus 1 and 2x minus 5. Its area is 1,150 centimeters squared. What are its dimensions? So length, width, 3x plus 1, width is 2x minus 5. So the area of a rectangle is length times width. If I combine those expressions, I have 2x minus 5 times 3x plus 1. And we know the area is 1,150. So that's equal to 2x minus 5 times 3x plus 1. So in this case, we're going to graph y equals the left side, 1150. We're going to graph y equals the right side. And we're going to see where the two graphs meet. So 2x minus 5 times 3x plus 1. And determine where they cross. Okay. So let's pull out our graphs. Let's open up our browser, desmos.com. Graph the line y equals 1150, and then graph the line y equals 2x minus 5 times 3x plus 1. And y equals didn't show up. There we go. We zoom out. Going to go to all the way to 1150, so you have to find the larger y value. And there it is. So there's my red line, my blue parabola. Find where they both meet. So they meet at 15 and at negative 12.8. Okay, but we can't have negative values of length. That wouldn't work in this situation. So we're going to take the positive y value. So we're going to say x equals 15. So therefore, x equals 15. And if I plug it in, so my length is, so we're going to plug it into these 3x plus 1 and 2x minus 5. So 3x plus 1 equals 3 times 15 plus 1, which is equal to 45 plus 1, which is 46. And 2x minus 5 is equal to 2 times 15 plus 1, which is equal to 31. So here we have a width of 31, and here we have a length of 46. And it's centimeters because the area is in centimeters squared, so we have to specify our units for length and width as centimeters. And that ends this video.